This is question 33 in exercise 4.2 in Project Maths 2. We have to solve the pair of simultaneous equations, and our equation 1 in this particular case is p over 2 plus q over 3 is equal to 1/5, and our equation 2 is p minus q equals 7/5. So this will be far easier if we can clear away the fractions in both these equations and work from there. So to do that in equation 1, we're going to multiply every term by the lowest common multiple of 2, 3, and 5, which is 30. So we're going to multiply every term by 30. And in order to clear away the fraction on equation 2, we're just going to multiply by 5 because we only have one fraction and it is a fifth. So equation 2 gets multiplied by 5. So for equation 1, we're going to end up with 30p over 2 plus 30q over 3 is equal to 30 over 5. And then for equation 2, we're going to have 5p minus 5q is equal to 5 times 7 all over 5. Alright, now we'll take them and tidy them up a bit. So from equation 1, 30 over 2 is 15, so we have 15p. And then for the next one we have 30 over 3, which is 10, so that's going to be plus 10q. And then we have 30 over 5, which is just 6, so we have 15p plus 10q equals 6. So that's our new equation 1. Equation 2 is just going to be 5p minus 5q is equal to, and 5 times 7 all over 5 is just going to be equal to 7. And now what we're going to do in order to get our coefficients to match on our q's, we're going to multiply equation 2 by 2. So nothing happens to equation 1. It stays as 15p plus 10q equals 6. And we're going to multiply equation 2 times 2. So we get 10p minus 10q equals 14. And now it's going to do that sum out. So 15p plus 10p is 25p. 10q minus 10q is 0. And 14 plus 6 is equal to 20. So we get 25p is equal to 20, which means p is equal to 20 over 25. So p is equal to 4/5. So that's our value for p. And now in order to get a value for q, we have to put this value for p back into one of our equations. And we're going to go back to our original equation 2 for this. So instead of p minus q equals 7/5, it's going to be 4/5 minus q equals 7/5. And if we then bring the 4/5 over to the right hand side of the equals, we're going to have minus q equals 7/5 minus 4/5, which means that minus q is equal to 3/5, but we don't want minus q, we want positive q, so let's change the signs on both sides. We get q is equal to minus 3/5, and that is that.